Hey class, so this is the first video out of two videos that are going to go over 6.1 and 6.2. Now, it's always helpful to remind yourself of specifically definitions in math, because sometimes you get to a point to where you've been doing example problems for a couple weeks, and maybe you've forgotten exactly what the terms mean in those problems. So it's oftentimes good to refresh your mind on, oh, okay, that's exactly what that term means. This is how we proved it. This is how we got this relation and all of that good stuff. So hopefully by going over all of these terms, maybe when you go back to the examples, they clear up and you can understand them a little bit better. Without further ado, let's get into the video. So we start off with a vertex, and just remember that a vertex is just a line connecting two points, but it has an arrow giving it a direction. So if we have just 2 points right here, A, B, vertex is just a line going through them. It starts at A and goes through B. And we just call that the vertex AB. And this again, this is our unit for angles. So angles are made out of two vertexes, right? And these vertexes are going to have their own definitions when in the context of angles. So an angle is made up of two vertexes. We'll put one going this way, and we'll put one going this way. And again, we'll get to standard position later, but typically this will be the initial side. Oh, sorry, I was going to write the word initial. This is going to be our initial side right here. Or initial vertex or side, whichever word. Initial side or initial vertex, and this will be our terminal side. And again, to get from the initial side to the terminal side, we have to go through a rotation of some measure, right? Now, when you sketch a positive measure, that means that you're rotating in the counterclockwise fashion. So just like what we drew here. So this is actually an angle of positive measure right here. And this is just a general angle made up of two vertexes with an initial side and a terminal side. Now, we then want to place this vertex, the starting point of this vertex, of these two vertexes, at the origin 0, 0. Okay, but maybe I'm getting ahead of myself. Let's see. No, I'm not. So when we place this vertex, the starting point of both vertexes on the origin 0, 0, this is what we call standard position. So this is an angle in standard position. Okay. One of the reasons why I drew the initial side straight and pointing to the right is because the other condition for standard position is the positive x-axis. So the initial side has to be on the positive x-axis. Initial side on the positive x-axis. Now, when you sketch the coordinate plane and label the four quadrants, you can see that you'll get an angle. Let me just erase this. I'm going to pause the video and erase it. 1 second. Okay, now that we've covered angles and their standard position, I've labeled the four quadrants on a coordinate plane, and I've drawn some angle with the red being the terminal side and the blue being the initial side. So coterminal angles, remember, are angles with the same terminal side, angles that share a terminal side. So actually there are infinite coterminal angles for any given angle side. For example, in the one that I've drawn here, we have this rotation marked by this arrow right here, and then we can also make another rotation like this. Sorry if that's a little messy, but a full 360 degrees away or more than that blue terminal side, and we end up with the same exact angle. So in order to find the coterminal angles for any given angle, all we're going to do, theta c, is we're going to add a factor of 360. So theta plus 360 gives a coterminal angle. Theta plus 2 times 360 gives a coterminal angle. And we can do this infinitely many times. So we just say that a coterminal angle theta c is equal to theta plus k times 360. And this is how we get coterminal angles given a certain angle. Okay, and when we talk about central angles, these are going to be angles in standard position that are central or in the center of a circle. So this initial side right here is on the x-axis because it is in standard position, and then the terminal side can be anywhere in the xy plane. It just has to cross the circle at some point. Once it crosses the circle, this part of the circle that is kind of contained within the angle, if you will, this is going to be what we call the intercepted arc. Because it cuts off the circle at 2 different points. When we talk about the variables that denote the intercepted arc, that's going to be s. And again, you remember that s equals theta times r, right? And again, this is not something you have to memorize. You'll be given it on any kind of exam or test. The next thing that we can talk about is what a radian is. So a radian is the amount of rotation that it takes for s to equal r. So we want this intercepted, this green line right here, to be equal to r, okay? And right from this definition, we can see that the theta in this equation has to be in radians, right? Because if we make theta equal to 1, then we get s is equal to r. Now, how do we find what a radian is in degrees? Well, I've talked about proofs and things like that in class. And the way I did it was I just found, okay, well, what happens when theta is 360? Right? So we know s is theta times r, but we're not going to use that. We're going to look at the circumference. So when s is 360, or when theta is 360, right? We've gone through the entire circle, and that means that s is equal to c, the circumference, which is 2 pi r. Right? And right there we can see that, again, looking at our s equals theta times r formula, we see that 2 pi is equal to 360. Okay, so this is the amount of rotation that it takes to go the entire way around the circle. So that means that 2 pi is 360. So when we find that 2 pi is equal to 360, we simply divide 2 pi on both sides, and we get that 1 radian is roughly 57 degrees. I think it's 57.3, but I'm not sure. But that is the amount of radian is, okay? And with this 2 pi equals 360, we could then talk about converting angles from degrees to radians. And when we convert from degrees to radians, so we'll do degrees to radians. We want to multiply by pi over 180. This comes from 2 pi is equal to 360. So then that means that dividing by 2, pi is equal to 180. And since we want to cancel out the degree measure, we put the degree measure on the bottom and the radian measure on top. When we go the reverse way, radian to degrees, we simply multiply by the reciprocal of 180 over pi. Okay, so we can simplify the coterminal formula now in radians. So we talked about how we found coterminal angles theta c by taking theta and adding k times 360. Now that we know that 2 pi is equal to 360, we just simply say that theta c is equal to theta plus k times 2 pi. That is going to be the new relation that we have. Okay, so that's it for 6.1. I'm actually going to pause the video here since we're at 11 minutes and go ahead and make a new video for the 6.2 review.